The core point of this cone, which is this point right here at the very top, lies directly above the center of the base. So that means that if I draw a line from the center of the base to that point, it's going to be perpendicular to the base. And that means that I can draw a perfect right triangle from the center to the edge of the base and to the core point. And I've got a right angle here. And that's going to help me find some of the measurements that I need. So first of all, if we're told that the width of this cone is 5 centimeters, we can figure out that half of that will be the radius of the base. So 5 divided by 2 gives us 2.5 centimeters. And the other measurement that I'm going to need is the height here, even though I won't need that right away. But I'm going to use the Pythagorean theorem to figure that out. So I'm just going to do that on the side here. And I know my hypotenuse, so I'm going to say 8 squared minus 2.5 squared will be the height squared. So 64 minus 6.25 is the height squared. And if you solve that, you will find that the height is equal to 7.6 rounded centimeters. So I'm going to mark this 7.6. You can also do this in fraction form if you like. I'm going to do it in decimal. Okay, now we can start answering some questions. So let's start with the lateral area. What is lateral area? So the lateral area is just the surface area, not including the base. And if there was another base, if it was a cylinder, we wouldn't be including either of the bases. So lateral area is equal to pi times the radius times the slant height. So 8 centimeters here is our slant height. 7.6 centimeters is our actual height and volume. So I'm going to write pi times the radius, which is 2.5, times the slant height, which is 8. And that brings us to pi times 20. In other words, 20 pi. So for the surface area, all I have to do is add the area of that base to the lateral area, which I already have. So I'm going to say 20 pi, which is our lateral area, and I'm going to add pi r squared, so pi times the radius squared, 2.5 squared. And that gets us to 20 pi plus pi times 6.25, and you can add those together to get 26.25 pi. And that, of course, the lateral area is in centimeters squared, and the surface area is also in centimeters squared. Okay, so now we're on to our volume. For volume, we're not looking at the slant height, we're looking at the actual height. So the formula for volume is 1/3 of pi r squared, which is our base, times the height. So 1/3 of pi r squared, which is the volume of the, which is the area of the base, and we already figured that out for the surface area, so it was pi times 6.25, and I'm also going to multiply by the actual height, which is 7.6. And if you solve that out, you will come to 15.83, or you can round that to 15.8, and this time we're talking about centimeters cubed. So if you look at the answers that are provided, those are in fraction form, so you can solve those fractions if you want to check that this is the same, or you can solve your own in fraction form. It's up to you.